Salam and welcome everyone. So today we're going to be working on the question on the screen that says consider 10 mole of a gas confined in a volume of 2.0 liters at a temperature of 300 Kelvin. The gas behaves according to the van der Waals equation where A is equal to 1.370 liters square bar per mole squared and B is equal to 0.0387 liters per mole. So this question is one of the questions that I got out from a session from a student. So a student came with this question. And yeah, we solved it together and I thought it would be a good addition to the channel. So the first thing you have to know is when you have a question like this, a physical chemistry question, especially in thermodynamics, you have to write out all of the parameters. The first parameter or the first information we're given is the number of moles, which we're told is 10 mole. So that is it. Literally, number of moles is 10 mole of a gas confined to a volume of 2.0 liters. We've been given the volume to be 2.00 liters at a temperature of 300 Kelvin. We've also been given the temperature to be 300 Kelvin. The gas behaves according to the van der Waals equation, where A, the parameter that involves strength of attraction, A is equal to 1.370 liters squared bar per mole squared, and then of course B, which is the parameter or yeah van der Waals parameter that involves the information on excluded volume. So A is strength of attraction, B is excluded volume. So then you've got B to be 0.0387 liter per mole. So we're told that this gas behaves according to the van der Waals equation. So what this is telling us that in order for us to solve it, we have to use the van der Waals equation of state. So therefore, the van der Waals equation of state is just simply P, pressure, is equal to RT divided by the molar volume minus B minus A divided by the molar volume squared, where R where we've been given the temperature. I'm going to come back to R, by the way. We've been given the temperature already. We've been given the value for B. We've been given the value for A. We are not given the value of the molar volume, but note that the molar volume is simply just the volume divided by the number of moles. So we can easily calculate it here. So we're basically giving molar volume indirectly. But then we have this R. And you're going to be wondering, how do I solve R? Well, the first thing, anytime you give me a question like this, they don't always have to give you the R value, but note that the value for R is always going to be 0.08206 or 8.3145. Now, it can be any of these two values, but the way you're going to know what you're supposed to use is for you to look at the units. 8.3145 can either be joule per mole Kelvin, it can be meter cube Pascal, okay, per mole Kelvin. It can be all of those things. It can, in fact, I would advise you that after you watch this video, go online and see gas constants, different values. You can see up to like 10 different gas constant values, and the only thing that changes is your units. Now, when you look at 0.08206, the most common one is just dm cube atmosphere per mole per mole per mole Kelvin. So this is the most common one, 0.08206 dm cube atmosphere per mole Kelvin, which is the most common unit. So it is going to be this one that we're going to use. As you can see, we did not have anything involving meter cube in our question. We did not have anything involving Pascal in our question. Here on the other end, we have dm cube. Dm cube is the same thing as liters. So actually, we can rewrite this formula as we can actually rewrite the gas constant as 0.08206 liters atmosphere per mole Kelvin. So this is what we're going to be using because when we look at our question, we're told to solve for the pressure. Pressure is the only thing that we don't have here. So we're supposed to solve for the pressure. When we solve for the pressure, it's going to end up being in atmospheres. But before we go on to solve it, we see volume matches dm cube, we see mole, we see Kelvin. The only thing now that is different is the fact that the units for pressure in the value for A this particular parameter, the van der Waals parameter A is bar. So what we can simply do is that we can recalculate our work and convert from bar to atmosphere. So we're going to do a unit conversion before we start substituting anything into our equation. So hence we also have the gas constant. We have gas constant R, we have T, we have molar volume, which we can easily solve for. We have the value for B, the value for A, and basically we have all the values we need to substitute. The only thing we need to do now is we have to do a unit conversion and we have to determine the molar volume based on the information of the volume and the information of number of moles. I know it looks like as if I'm rushing. I don't mean to, but yeah, that's basically what we're supposed to do. So to calculate to go from the parameter A is equal to 1.370 liters squared bar per mole squared. We're trying to go to L squared atmosphere divided by mole squared. So this is what we want um, our final unit of A to B. So it's just basically us going from bar to atmosphere. And that's what we're going to use in this question. So we have to remember that one atmosphere is actually going to give you 1.01325 bar. And here we're given 1.370 bar. I'm not going to write the liter square and mole square because we don't need to write that. The main concentration for this question is just the bar as well as the atmosphere. So yeah, so far so good. So this is equal to x. We're going to do the unit conversion, cross multiply. We end up with x is going to equal 1 atmosphere times 1.370 bar divided by 1.01325 bar. Cancel out the bar. And then, yeah, we just have x to equal 1.3521. Okay, when we do the division in our calculator, we end up getting 1.3521 atmosphere. So we can rewrite the value for A, strength of attraction, to be equal to 1.3521 atmosphere. And then we've got the value liter square, okay, divided by mole squared. So this is basically now a new value for A. So we have the value of A in the proper way. Now we have to remember that we're told to solve for the molar volume. What did we say the molar volume again was? We know the molar volume to be volume divided by number of moles. We're given our volume to be 2 liters, 2.00 liters, and number of moles to be 10 moles. So that would be volume divided by number of moles. So the liters or the volume is just 2.00 liters divided by number of moles to simply be, or which is simply 10 moles. So yeah, molar volume ends up becoming 2.00 times 10 raised to the power of negative 1 liter per mole. Or we can just simply say molar volume is just 0.200 liter per mole. So yeah, that's it. Now, before we substitute all of this into the equation, I just want to rewrite all of our parameters so we're not confused. We already have the value for A, which we did the unit conversion for. We have the value for molar volume. We know our temperature to be 300 Kelvin. Okay. And we also know our B to be 0.0387 liter per mole. So temperature is 300 Kelvin. And then the value for B is 0.0387 liter per mole. So we can just simply substitute. So pressure is just going to be RT divided by the molar volume minus B minus A divided by the molar volume squared. So pressure is equal to 0.08206 liter atmosphere per mole Kelvin times 300 Kelvin divided by the molar volume, which is which is 0.200 liter per mole. So 0.200 liter per mole minus the value for B, which is 0.0387 liter per mole, minus the value for A, which is 1.3521 atmosphere liter square per mole square. So 1.3521 liter atmosphere liter square per mole divided by 0.200 liter per mole all squared. So yeah, that's basically what you've gotten so far. And this is it. This is basically it. Of course, we're scientists, so we know that the best thing for us is to start canceling out anything that can be easily cancelled out. So we see a situation here where we can cancel out the units for temperature, so Kelvin, Kelvin. Yeah, we have that, so we can just continue our calculation. 0.08206 times 300 will give you 24.618. And then, of course, we have the unit liter atmosphere per mole. So that would be liter atmosphere per mole divided by 0.200 minus 0.0387 liter per mole will just simply give you 0.1613 liter per mole minus 1.3521 atmosphere liter squared per mole squared divided by 0.200 liter per mole squared. That's just simply 0.0400 liter squared per mole squared. Yeah, that's it. So yeah, now we can successfully cancel stuff out. We can cancel out the liters here, cancel out the liters, cancel out the mole, cancel out the mole, cancel out the liter square here, cancel out the liter square here, cancel out the mole squared here, and cancel out the mole squared here. What we have left here on the left side of the negative sign is atmosphere, and what we have on the right side of the negative sign is atmosphere. So next we have pressure is equal to 24.618 divided by 0.1613 is going to give you 152.62244. Let's not forget our atmosphere. So atmosphere minus 1.3521 divided by 0.0400 is going to end up giving you 33.8025 atmosphere. So we're just going to simply do the subtraction to get the pressure. So when you subtract this and you input this information in your calculator, you end up getting 118.81994 atmosphere. So this is basically the answer to the question. But our work is still not done. We have to put our work in the proper number of significant figures anytime we're doing chemistry questions. So we go back to the when we scroll up, we're going to go back and we're going to see what is the lowest number of sig figs that we're given in this question. We can see that 300 is in 3 sig figs, 2.00 is in 3 sig figs. The value for A is in 4 sig figs, and the value for B is in 3 sig figs. So when we now know this, we're going to put our final answer in 3 sig figs. So we're going to approximate to 3 sig figs. So the pressure ends up equaling 119 atmosphere. And this is basically the answer to this question. So if you have any question based on what we just solved, just try and rewatch the video. And if you still have any questions, or even if you have suggestions or concerns about this particular question or the channel in general, put it in the comment section. I try my best possible to answer you guys whenever you have that. I also wanted to note this one more time, that this is a student question. So if you are trying to succeed in any of your assignments or classworks and you want me to work on them, you can email me at shahabitutoring@gmail.com and give me all the information you need in order for me to solve it. And I'm going to put it on my channel just like I did this question. Before we end the video, I want to quickly mention that if you're a student who is struggling in any of your STEM related courses, whether you're in middle school, high school, or university, make sure you email me at shohabitutoring@gmail.com. I help students succeed in all their STEM related courses, as well as I mentor them through academia or through their journey in academia. So if you love the way I tutor and the way I explain and break down information for you guys' understanding, make sure you email me at shahabitutoring@gmail.com. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.